Unit 6 is kind of a jumble of stuff, and you'll notice today where it might be frustrating for you because you just finished solving equations with multivariables, and then we're kind of doing something that's completely different. The reason for that is you're jumping into one of the first units of Algebra 1 from Go Math. It's like the traditional Algebra 1 textbook that high schools possibly use, and they are giving you like an overview of all things algebra. So we've already done some word problem things. Did we do equations? 2-2? Was equations the one we did on? That was last year, but we did a little bit in the warm-ups. I was thinking, oh, what did we do Tuesday this year? Or this week? What was Tuesday? It's just so different. We'll go back and review everything before your test because it's just kind of a mix of things. And today's is solving inequalities, which is another just algebra skill we need to have in our pocket. It's very similar to solving equations with one slight difference. Here is the difference for your equation versus an inequality. An inequality is a statement that compares two expressions that aren't just equal. They don't have an equal sign, and they use one of these symbols. If you know what one of these symbols means, raise your hands. Give me the first one, Felix. What is that symbol right here? Yeah, this is a greater than symbol. If that's greater than, we're reading left to right, kind of like a book, so this symbol would be less than. When you have a line underneath it, it automatically makes it greater than or equal to. And then the reverse of that, reading left to right, would be less than or equal to. Wyatt?
So for those of us that were in robotics, we worked with those symbols so much in the little computer input.
That's awesome. That's super cool. I don't do robotics, so I did not know that was a part of it. But raise your hand if you're in robotics.
I'm pretty sure maybe all of us were.
Raise your hand if you were once in robotics at one point. Hands down. Almost all of us. So this is just like a part of why. Thanks for bringing that up, because this symbol doesn't really appear a ton. It's not like a consistent thing you see in 8th grade, but it just is mostly like actually 7th grade. Math is the big like hurrah of all your inequalities. You guys kind of skipped 7th grade math because you took 8th grade math with me last year, so this might be kind of new. But you're so good at equations that it shouldn't be too difficult today. 6th grade, you don't really work with inequalities. It's like barely. You're kind of looking at just like comparing the numbers with inequalities, but you don't actually solve an equation. With 6th grade, you don't solve it though. With 7th grade, you solve it. You might have solved it because your teacher was cool, but I don't know. I think he may have actually taught you 7th grade math too. He did. He was teaching you 7th grade math in 6th grade.
And he, by the way,
I'm gonna pause you. This is going to be a. We're not going to use this symbol today, but this is just not equal to. If it just has a dash, kind of across the equal sign, it's not equal. We're not going to use it today. What do you mean? What do you mean? For an answer?
Like 4 and 5, you just go not equal.
Instead of writing greater than, you just write they're not equal to each other.
Because there's always a greater one. So what's the point of that one?
No.
Oh, because then you could do like 5 plus 5 is not equal to 4 plus 1.
Example 1, it's going to ask you to solve these things, and solving them is going to be just like an equation. It's almost as if this were to just look like this problem. This is something you've seen before. It just has one slight difference, and we'll look at the difference in example 2. For now, let's just solve this guy like we would normally. Keep the greater than sign. Tony.
When you add or subtract to one side, do you switch around the greater or less than sign?
Not when you add or subtract.
When you divide.
Divide and multiply, we're going to see an example 2 that there is a trick to that. You did in 7th grade, barely. I threw like one lesson at you. Yeah. 6th grade maybe? Okay, yeah. Mr. J taught you guys 7th grade math in 6th grade. Right. Yeah. Okay, so add 6 to both sides. 3x is greater than, the biggest blunder you're going to catch me on today and maybe the next few days is I write equals just automatically because I do so much equation work with 8th grade math and with 7th grade math that will oftentimes just kind of be a blunder I make. Don't make that blunder yourself. Divide by 3, and this answer is x is greater than 1. That means that all of the answers that would work for this are bigger than 1. The answers cannot be 1 to make it true. So you could have the answer as 2. You could have the answer as 3. The answer for x could be 4, 5, 10, 100. Any number bigger than 1 will work and make this true. Elliot. You don't. And it's only if you'll see an example too, it's only a negative number that would make this thing kind of break. A positive does not need to flip. Let's check this out real quick. On the side, I want you to just throw in a few random numbers to see if we can check to make sure it's true. Any number bigger than 1 is going to probably make this work. Give me a number between like 2 and 10 that you want to use to check it, Tanner. Okay, so let's put 7 in for x. If you solve this thing, you should have a number on the left side that's bigger than negative 3. Let's see if it worked. 7 minus 2 is 5. 5 times 3 is 15. So 15 is bigger than negative 3. This works. Wyatt. Where? Here's why. If you have numbers in parentheses, you can simplify that because they're like terms. So 7 minus 2 is 5. If you don't have numbers, like a variable in a number, you would have to distribute. Correct, yeah. Same thing. Let's take a look at one that doesn't work. Let's take a number that's 1 or less than 1. Let's use 0. 3 times 0 minus 2. And if this is less than 1, or 1 exactly, it should not work. 3 times negative 2 is negative 6. Negative 6 is not bigger than negative 3. That doesn't work. So this is not an option that works. X cannot be 0. You do not need to show this work. I'm just giving you an example of what's happening in inequalities and why it's a little different than equations. Last example. It's kind of a big one. Let's see what's going on. I want you to rewrite this on the top. I'll take your question. Hands up if you have a question. Kieran, Jackson, question before I move on. Wyatt, question. Tanner, question. No? Okay. Rewrite this next to it so we have room to work. We're going to use a lot of space below it. First step that I would do to solve this, give me an idea of what you would do, Sarah, Tony. So we're going to follow the same orders of equation solving, and we're going to distribute first to simplify this. That gives me negative 27x and negative 60. You have two different steps you could take. I could move the variables or move the constants. Both would work. Just give me what you want to do, Sasha. What would you end up moving first? Sure. Seventh graders learned yesterday and today that you are the ruler of algebra land. Whoops, that's not crossed out. And remember, you can like choose wherever to start as long as you move the constants to one side and the variables to the other. 15x plus 40 and negative 27x is greater than or equal to. Next step, let's move the 15x because we want to create peace in algebra land. Variables on one side, constants on the other. That's a 40. And negative 27 and negative 15 is negative 42. Here's your trick that a few of you alluded to. The moment you have a negative number that you multiply or divide on both sides, you need to flip the inequality to reverse it. So if you divide by a negative on both sides, this inequality flips from a greater than or equal to sign to a less than. When you divide by a negative, it essentially kind of like breaks your inequality, and you need to reverse this to make it work again. So dividing or multiplying by a negative, you flip the inequality. X is left over, and you get negative 40 over 42. Could you simplify that? 20 over 21. Okay. There's your answer. All values of x that are less than or equal to that fraction are going to work to make it true. Here's your big idea. It's important, so it says important. Go figure. The inequality sign must be flipped. Always flip it only when you multiply or divide both sides by a negative number. Put your name at the top of your appointment book.
An appointment. Appointment is such a good word, but it rhymes with appointment. So first thing that comes to your mind. No, because look at it. Appointment is just a word, right? Appointment. The word
I printed
is a
extra.
weird word. Appointment rhymes with ointment, and I don't like it.
Appointment is pretty weird.